Welcome. In a past video here, I talked to you guys about using the quadratic formula, and we did a few examples with it. But in this one, I want to do something a little different in that rather than using it, I want you to understand what the formula is that you're using and where it comes from. So that's what we're going to talk about today. So we're going to actually prove the quadratic formula, or basically, given a polynomial or a quadratic of the form ax squared plus bx plus c equals 0, I want to prove that the solutions, the zeros, the roots, whatever you want to call them, are x equals negative b plus or minus square root b squared minus 4ac all over 2a. That's what I want to show is true for these zeros. To do it, basically you use the completing the square method. So in essence, completing the square did come before quadratic in that it's used to prove it. So let's get into this. So first off, if you recall from when we talked about completing the square, first thing I want to do is to take this term, which does not have an x, and move it to the other side. So I'm going to get ax squared plus bx would equal negative c. Now, when your leading coefficient or the coefficient in front of your highest term is not 1, what you want to do is to make it 1. So I'm going to divide all terms by that a, so that now I have a 1x squared plus a b over a times x. And I'm going to leave a little blank space here because there's something I'm going to need to add to both sides in order to complete the square. So how do I know what to add here? Remember, what you do is you take your b term here and take half, or you take half of your b and square it. But here's the thing. After we divide by a, my b term is not b anymore. It's really b over a. So I basically do something of this nature. I take my b term, or my coefficient in front of my x, and I divide it by 2, or I take b over a, I divide it by 2 and square it, and that's what I'm going to add in those boxes. Now, if this seems a little messy for you here, rather than saying taking b over a and dividing it by 2, that's the same as taking half of b over a and squaring it. So when I take half of b over a, you multiply the numerators, multiply the denominators, I get b over 2a squared, which is b squared over 4a squared. So that's what I'm going to add to both sides. From there, we're going to factor. And I think it's probably a good idea to get common denominators here. So to turn this a into a 4a squared, I'm going to multiply the bottom by 4a and also the top by 4a. So I'm going to get both terms having a 4a squared on the bottom. And then if I take 4a times negative c, it basically makes a negative 4ac, and then plus a b squared here. And the factoring. If you look at this, you might say, how am I supposed to know what multiplies to make b squared over 4a squared and then adds up to b over a? How am I supposed to know that? If you recall, I talked about when you take your b term and divide it by 2, what you get before you squared is what goes into the factor. So when I took half of my x coefficient, I got b over 2a. That's what goes here. And if you were to multiply these, it would give you the b squared over 4a squared. And if you were to add b over 2a plus b over 2a, it'd give you 2b over 2a, which reduces to just b over a. So now it's factored. From here, we're going to go ahead and when I say x plus b over 2a times x plus b over 2a, that makes x plus b over 2a squared. And then here, now we have the common denominator of 4a squared. And then I just combine the numerators and I get negative 4ac plus b squared. So let's continue on to the next page here where we have a little more room to write. So I have x plus b over 2a quantity squared is equal to, and I want to rewrite this a little differently in that instead of saying negative 4ac plus b squared, I'm going to use the commutative property of addition, which basically says if I take an a plus b or a b plus a or a 6 plus 5 and a 5 plus 6, the order you do it doesn't matter. So instead of negative 4ac plus b squared, I can really say that's b squared minus 4ac. So you should start to see this looking a little bit more like the quadratic formula now. So from here, I'm going to eliminate that squared by square rooting both sides, which is going to give me x plus b over 2a equals. Now, if you recall again, whenever I'm dealing with a squared here or a highest power or a degree of 2, means I'm going to get two answers. So when I square root this side, it really is plus minus b squared minus 4ac all over 4a squared. And next I'm going to go ahead and since these are being divided, I can separate them. So that's b squared minus 4ac inside of the square root on top, and then the 4a squared on the bottom, which is kind of nice because it leads me to here. The plus or minus b squared minus 4ac inside of the root, which I definitely don't want to mess with because I know that that's part of the quadratic formula. And if you recall, in past video, I talked to you about this b squared minus 4ac being a special component of the quadratic called the discriminant. So I don't want to mess with that. I need that. But here, when I square root 4a squared, well, the square root of 4 is 2, and then the square root of a squared is just a. So hopefully you're starting to see here that we're really getting close to developing our quadratic formula here. So what remains to do next is to subtract b over 2a from both sides. So from there I get x equals, well, the square root of b squared minus 4ac over 2a minus the b over 2a. So we go ahead and put it over a common denominator, 2a, and I get, oops, there was a plus minus here. So I get the plus minus, or positive negative, square root of b squared minus 4ac, and then minus this numerator, b. So to finish this up, all I have to do is, again, use my commutative property. You know, when I say 2 plus 7 or 7 plus 2, order doesn't matter when you're adding. Same deal here. So instead of saying this plus or minus square root of whatever minus b, I can actually say negative b plus or minus the square root of b squared minus 4ac all over 2a. And ladies and gentlemen, that is your quadratic formula derived from completing the square. QED, little Latin lesson for you. Quod erat demonstrantum, meaning thus it is demonstrated. I hope this helps, and I hope you enjoyed it. Thank you.